Perpetuities are another type of investment, and they relate very, very strongly to an interest-only loan. So the maths involved in this kind of investment is exactly the same as an interest-only loan. So in the same way that an annuity was the same as a reducing balance loan, except the money went in the opposite direction, this is exactly the same with a perpetuity. The money goes in a different direction. Exactly the same maths though as an interest-only loan. Okay, so with this kind of investment, what happens is someone invests money and takes a payment regularly from that investment, but they never ever touch the investment. They only ever take the payment that is the amount of interest that's earned. So again, the principal never gets touched. The payment comes from that investment to the person who invested it, but the payment is never any bigger than the interest that's earned from the bank. Okay, so to go through a couple of examples with you and show you what I mean by that, this example 14 is a very simple one where Elizabeth invests her superannuation payment of $500,000 into a perpetuity that will provide a monthly income without using any of the initial investment. The interest rate for this perpetuity is 6% per annum, and we're talking monthly payments, so we need a monthly interest rate to calculate. And really all that means, you don't need to use the solver, it's a very straightforward calculation. If we calculate the monthly amount of interest that would be earned on a $500,000 investment, we can do that by doing 6% divided by 12, multiplied by the investment, which is 500,000. The answer is 2,500. So the interest earned on that investment is 2,500. And if Elizabeth takes that monthly payment of 2,500, it leaves her again with an investment of 500,000. When the bank calculates that interest the next month, it earns another 2,500, and she takes the 2,500, leaving her again with 500,000, and it just goes on and on and on. So perpetuity basically just means something that goes on forever, infinitely. Really all it's meaning is that $500,000 stays there indefinitely if she only takes an interest payment from that. Okay, so you're looking for the word perpetuity, something that says maybe indefinite, the words in there that you're looking for, meaning that the investment is never going to be touched, the principal's never going to be touched, only the interest gets taken away. So when we're using that information to calculate some of these other examples, we might get asked something like how much money would need to be invested in a perpetuity account. They give us the information about the interest being 4.2% per annum, compounding monthly. If the payment that's going to be withdrawn every month is $200, how much would need to be in there in the first place in order to earn a $200 interest payment? So because you know if I take the percentage of the amount, and I know that has to equal to the payment, I can use solve on my calculator to do that quite quickly and easily. 4.2% calculated monthly of something has to equal to 200. What is that something? And we solve it for X. When we round to the nearest dollar, we figure out that we need $57,143 invested in order to earn a $200 interest payment. Okay, so when you're reading these questions now, because there's so many different types of investments, we need to really be reading every single word of the question and looking for hints as to what sort of investment is it, what do I know about that sort of investment, get my notes and have a look, how am I going to solve this one. We could be asked as well to calculate an interest rate relating to a perpetuity. And you can see there, I'm showing you first how you can use the solver, but I rarely, if ever, use the solver for a perpetuity, but I'll show you that as well because some of you might like this method as well. So in this case, a university maths faculty has $30,000 to invest. So it intends to sort of invest this money, earn some interest, and take a prize. So they take out the interest and give that interest payment to someone as a prize. And the idea of a perpetuity investment here would be that the $30,000 just stays there, and then each year it's earned another $1,500, another $1,500, another $1,500 for that prize. So they can keep giving a prize forever and ever, without ever touching their initial investment. Okay, so that word there, what's the minimum investment rate that will allow this to this prize to be awarded indefinitely? So as soon as you see indefinitely, if it doesn't say the word perpetuity somewhere else, which I can see that it does, that indefinitely should be a hint in terms of this is a perpetuity investment. It's got to last forever. So if you're using the solver, you actually only need to put in there n equals 1, because all of the compounding periods are the same. It doesn't change from one year to the next. They're all the same. So you can do 100 if you want to, or 1, or 6, or 9, or whatever. It doesn't make any difference. They're all going to be exactly the same. So you can just put 1 in there if you wish in the solver. So if n is 1, we leave the interest rate blank because that's what we're supposed to be finding. The PV is negative 30,000 because we're investing 30,000. And this is a bit that sometimes confuses students, that the PV is invested at 30,000, and basically we want the FV to still be 30,000 after this calculation, with a payment of 1,500 in there. The word annual up here tells us that PPY and CPY only need to be 1. It's just one calculation at the end of the year. But it's probably the 30,000 FV and the negative 30,000 PV that's going to be the bit that will bother you if you're using the solver. So if you do that and use the solver, you will get an interest rate of 5%. For me, I don't use the solver for perpetuities in general. If I don't have to, I use a simple calculation like this one down at the bottom of this page here. Because I know with a perpetuity that the interest payment's got to be the same as the payment, what I would need to do down there is, if I said $1,500 payment out of a $30,000 investment as a percentage is what, I get the 5% that way. So you can do that kind of shorter, simpler calculation with a perpetuity, just like you can with an interest-only loan. Okay, so the practice questions for that sort of situation come from 9F. Just to show you graphically too, over the page there's a VCAR question, and there's quite often one of these on a multiple choice where you have to choose which graph relates to a perpetuity. So in this one here, Juanita invests an $80,000 amount in a perpetuity that will provide $4,000 per year to fund a scholarship at a university. Which graph shows this? So basically, as long as you know she's invested $80,000 and it is a perpetuity, it doesn't matter. Any of the rest of the story doesn't make any difference to this question at this point. So we want to find a graph that shows that every single year after the other, one after the other, has a value of 80,000. And that one looks like B. So after 1 year, there's $80,000 still there. They give out $4,000 as a interest payment, but there's still $80,000 there for the next year. Then it earns $4,000 payment, that goes away, it's still $80,000. So you've got this sort of straight line graph there. The only other one that would be worth even looking at in that question would be E. Sorry, no, it's not E, sorry. A. So that's the only other one that's a straight line. And that is looking like they're putting in the interest payment of 4,000, 4,000, 4,000, 4,000. So that one's in there as a distractor. Because it is a straight line, they think maybe you might choose that one. A straight line going horizontal. So really the only two options that would be even in the thought process of being chosen here would be either A or B. A is all about the interest. We're looking for the value of that investment over a period of time. So we don't even care about the interest. We just want to know how much is in that account at any particular year. So it has to be the $80,000 horizontal line, not the $4,000 one.